Right, so this is now the code explanation. So we're going to go through each individual class and explain how everything is organized. So the high overview of everything is that we have these files, which is our database backup, and then we have our audio files, which are also located within the bin, right? So they are located within the bin of the project, so that they're able to be played by the audio service. So there's a separation of logic within the application. So all of the logic that has to do with the pages is within pages. All the logic that has to do with database scripts are here, and then all the logic that has to do with this specific logic is all here. So it ensures that it's easy to maintain over time, because everything is now separated. So now we know if we want to deal with application logic, we open this, then we can see the core logic, and then we can see the data. The data is just, I don't know, okay, I should probably rename this to database, but so data is basically all of the database configurations. And so I made a provision for it to be adaptive to these following databases: so MySQL, SQLite, and SQL Server. So it makes it so whenever someone wants to toggle between the various databases, they're able to toggle. The reason why it's separated, is not in one file, is mainly because it's only to be more readable, and also when someone wants to do a configuration, remember there's a variance in syntax. So now, yeah, so I just wanted to make sure that everything would be modularized. So when people want to expand maybe to add Postgres, they can also add Postgres and all the various providers that they want to add, but just basically copying and pasting, just changing the connection system configurations. So within that class, so the connection strings, yeah, let me just open. So the connection strings are set here. So all we do is we just create a class, internal static class, right? And then we basically equate it to that connection string, right? So right now we don't have a MySQL connection string, but yeah, I think I'll add that, yeah, before pushing the code. So and then the SQLite connection is established. So you essentially just paste the connection string here, and then after that you can just update the database. You should be able to see the tables and continue with the whole flow. So everything is handled in terms of the table, the creation logic. Everything is handled within the class. So open this, for example, you can see when we open the MySQL file. For example, you can see that the name MySQL is configured here, and then this is in the synchronous task, right? And then what we're trying to, we have error handling in the sense that we need to check that the database is connected, because there are instances where people can forget to configure, and it needs to behave in that way so that people can know that it is not behaving in the appropriate manner. And then here within this constant string, right, we have our SQL statement that we're executing, where we're essentially creating the table where it exists, if it does not exist, right? And then, for example, we have the integer, we have the following parameters for. So we have the primary key, we have the sender field, the message field, and then the created enter field, which is the timestamp. And then we also have a table for reminders, right? So we open our connection here. I'm gonna close it at the bottom. So what's happening in this try block is that we are creating a connection object of the MySQL connection class, and then we are passing in the connection string as a parameter, and then we are awaiting the connection, and then we're opening it as an asynchronous function. Yeah, I think it's, yeah, so that it's more optimized, doesn't crash when processes are happening. So it allows for multiple processes to be happening concurrently across the threads. So now what we then do is we then also we create another object so that we can execute our SQL queries. So this command object is allowing us to execute our SQL queries, and then of course our connection object, which is at the top here, which contains all of the data we need to create our table and everything. And then await, and then the command. This alone executes the entire SQL query and injects it and creates the tables for us, right? But we need to of course have some error handling. So we need to ensure that that the column is red, right? And then once that returns true, and then we have a catch in the instance where it's false. Okay, so now when we then go to the second part of the database connection, we can see again another asynchronous function, right? So here I'm just trying to basically like have an insert. So the SQL query here is the insert command, and then within that we have our parameters, right, which is the sender and then the message. So the add sender and the add message are basically temporary variables that we are adding so that we can execute our query. So so these are basically our command parameters. So we then create another. We then open up the database again, right? Open up the connection again, and then after we've opened the connection, we instantiate our SQL query, which allows us to insert the tables within the database. And then now after we have done that, we then go towards the command object again, and similarly we have already predefined this connection string. So the connection string is now being passed in again, which allows us, and then we are adding the parameters that this class is expecting. And then now after passing in those specific parameters, then we execute our query. So this is the actual function, but we're executing around the command object. So we have control, right? And then this is just some basic error handling to ensure that doesn't happen. So essentially the entire class is just allowing us to execute and close queries. And then this is one for another task for the chat messages. So the chat messages, we want to also store those in the database. So we have the ID of the chat message, the sender, the message, and then the created at, and then of course the limit. And yeah, so all of these are basically the parameters, and then another insert statement again. Yeah, and then this one we're adding the due date is red. So this is for the tasks, the reminders. Yeah, so this is for the reminders, you see. So for the reminder DTO, you can see that in the parameters that this is for the reminder DTO. Here at the top, you can also see that this is, yeah, you can see that this is the chat message DTO, right? Right, and then so we have essentially everything within our database. So we have persistent memory in that sense that it is able to remember what you have asked. It is able to remember all the various queries. So even this aggregation function to basically count how many reminders are read. This is what we're using to display in the front end when we're counting, and we're basically showing like how many reminders have been read, how many reminders have been set. So just another basic SQL function that allows us to then execute that query. Of course, if there's some error handling, because we have to check if it exists or not, right? And since it's numerical, we're converting it to int. I don't think it will ever, 32, but I think 32 is enough. Okay, and then the last function is the same. This is the execute reminder async, and then our parameters is the string and the reminder, and then that's basically it. So we then of course have our connection object, and then our connection string, and then we're so now within the database connection string, we're obviously fetching the connection string object, and then that we open the database, and then we have another command, then we execute a command, and then that, and with that parameters we add a value, and then that is the reminder ID, then we await that, and then we return. So that's, so it's essentially this class and the other classes, they're doing the same thing. It's copy and paste, but obviously with this one is for, yeah, so they're all just doing the same thing, in the sense like they're all just essentially just storing it, and then they're collecting the connection string from this. So it's one place to configure, but all the logic is handled within these classes, and then that's essentially the data logic. And then within the models, so created them is the data transfer objects, because they just do that. They're not, there's no like business rules mainly with these. So for example, this one is just the sender, this is the message, and then the credited. So we're using this for the displays in the UI. So for example, the chat message DTO to essentially allow us to basically access these fields. So when we need to see who is the sender, we need to see what the message is, and then the date, the timestamp for our database purposes. And then the main menu. So the main menu or just has so the user question count, right? And the reminders. If you recall, so the reminders are set into an array because we have we don't really want to put a threshold or a cap on the reminders, because we don't know how many times the user might want to use the system. So we're storing that in a so that's why it's going to be within an array. But so now let's go back to the Solution Explorer and then just continue. And then there's our reminder DTO object with all the fields necessitated, and then we have our task assistant results DTO. So this one is just the reply and then the reminder, right? So that's essentially it. So it's modularized in that regard. And then here we have our responses. So if this one it doesn't look pretty, but it's what we had in part 1. So this is essentially the hard-coded responses that we are basically mapping using the hard-coded we're basically mapping these, right? Hard-coded responses. So these hard-coded responses, we are able to then access hard-coded response fields. So we're able to access these fields, right? We're able to access this field and this field. And because it's quite a lot, we're within this field. So we're able to access, for example, so there's the string here, right? And then there's a string array. So what's happening is that we have a string which is mapping to the initial keyword, and then we have a new array that we are opening up, which is containing additional keywords, additional phrases, which are then stored within that array. And then that is what we're iterating through when we're using our random function. So this is essentially the hard-coded responses which the chatbot is using, right? Okay. And then the randomization logic is here, right? So essentially we create a randomization class, and then we create our random object of the random class, right? And then we of course we have a function that says which is from the randomization class, right? Which is get random response, right? And then if not null, then or if the response length is equal to 0, return string is empty, and then return response random dot next. So the next is a pre-built method within the random class, right? So we are just using that next, right, to basically loop through what is next to go, but at random. So the logic is already pre-built for us, and then what is being passed in is the parameters, which is the response length itself, responses.length. So that so essentially we are able to then loop through our entire array across the length of it, right? And then it then picks at random what it returns to us. That's the random logic there. And then now with the services, so the chatbot voice is a bit so yeah, so there's a the chatbot voice is very simple. So we just have our chatbot voice class, and then we have a try and a catch block. I don't have a message in the catch block because I trust the code, but yeah. I could put a message here, but this works fine still. And then let me just, you know what? Just add the message. What can I add here? No file. Yeah, add no file. Yeah, just add a message here, just to not lose marks. Okay. Right. Yeah. Because there can be an instance where maybe somebody deletes the files. Okay, so you need to have that message. Okay, so now within this class, right, we're just basically using the try placing function, right, to play this file, and then if it's not there, it doesn't play. That's it. And then we just essentially just repeat the logic for each instance where we need to use the vocal logic. But so the sound, so we are then of course then using this player object, right, of the sound player class, and then we're using it to load and then play the audio. So that's the run logic behind this entire thing. And then this is just to make sure that we do find it in our directory to see that it's within the path. And then sorry, and then now we are in the responses. So this is where for the chatbot, where we are then looking in the sealed class, right? And then sub response service, and then we have our hard-coded responses, and then our sentiment analysis. So our hard-coded responses object and then our sentiment analysis objects are what we're going to be using to access our responses, and then our sentiment analysis fields. So what we do is we just take this object and just put a dot there, and then it will tell us what fields we can access from these classes, right? So just look out for that when we are then of course using it within our chatbot response. But that's essentially the whole logic. I mean this file is very small. So this is the build reply. So we just try, and then we say if like null or white spaces, user input. So making sure that there's no white spaces, right? And then we returning, please type a cybersecurity question so I can help, right? And then var emotional reply. So our sentiment analysis, so it tries to build our emotional reply, and then within that it takes in our one parameter, right, which is the user input, and then it outputs the detect emotion, right? So it detects the emotion of the from that statement, right? And then here for each response in hard-coded responses, right, we then of course check the user input if it contains that key in the responses, and then it can continue. And then if that, then we randomize it. We randomize that response value. And then after that, we then, you see, we then trigger that emotional reply. That emotional reply variable, which is executing the sentiment analysis methods here, and this info reply are then string concatenated to then form our sentence, which mimics our sentiment detection and our sentimental analysis. So this is where the sentiment analysis is residing. So within the sentiment analysis, we have emotional rules, right? So the emotional rules are essentially, this is mapping, right? So we're mapping words that, we're mapping emotions that are common, and then we are putting a lexicon in the sense that we want them to be essentially classified under one homogeneous group. But so when someone says happy, there are responses that are for happy. If someone mentions frustration or frustrated, or words that are tied to frustrated, then the responses are then mapped to this, so that it's easier to expand. So if we want to add additional emotional rules, we then can add our various dictionaries. For example, here with matches sad, here's a simple one. So contains any phrase. So sad, down, depressed, unhappy, hurt, heartbroken, lonely, empty. So all of these can be simplified and grouped into one specific lexicon, so that the detection is more accurate, because there's a lot of emotional words, and it's not really practical to create a robust one for each individual emotion. So we then obviously it detects the emotion, but then it responds based on the lexicon values. And then now the task assistant service. So the task assistant service. So now this one also has a dictionary, but I kept this in the same class. I didn't separate it like the output responses one. But so it's also mapping. Like here is a string field, and then here's the other parameter, which is the array. So here will be the for example, the two-factor authentication, right? And then it is now has the mapping to the various spellings of two-factor authentication, so that it's a bit more robust, because there can be instances when someone types 2FA, two-factor, MFA, all of them are essentially the same. So it needs to be able to respond and adapt to these variations of spelling. So that's why it is listed within an array. That's why it's not just like mapped to one string. I could have just done this, but I wanted it to be like, to be like that, so that you can have multiple options. And then so now what we then do is we then build the reply. Similarly, it's exactly the same logic, right? Exactly the same logic that we had previously. It's just now we just introduced regular expressions to clean our output for the reminder messages. But this is essentially the same sentiment detection logic that has been applied, and then the same string concatenation and string manipulation, which is still being used to help us return our values. If you can see on line 41. Alright, and then with the task voice, it's the same logic again. We're still using the sound player class. We're still using the sound player class, and then we're, of course, you can see the sound player class here, and then we're loading it, and then we're running it. But now we're just introducing a bit of lambda to practice. And then yeah, that's essentially all the services for the entire application. But now within our UI, what we need to see in the front end, that is also something that needs to also be showcased. So this one, it uses please give it a second to load. This application is quite heavy on my laptop. Alright, so there's our UI and our interface. This is our XAML. Um, and then this is the game page, right? And then this is the menu page. And then this is the task assistant page, right? So these pages, um, uh, yeah, these are the pages, and then what we need to then look at is the logic, right? So the main XAML is where most of the logic is residing. So let's go to the main XAML. So the main XAML is where we are essentially creating objects of these pages and calling them. Yeah, so yeah, I was reading on this whole notion of inheritance, in the sense that you can inherit page, you can inherit the pages and then pass in the objects of the respective pages to allow for pagination and navigation, right? So for example, if we look at this internal void, right, this is a function, right, which says navigate to menu, right? We've named it navigate to menu, right? Now we then say mainframe navigate new menu this object, right? So now here, this is the syntax, of course. Okay, if I can explain what's going on, right? So this is essentially the same way of saying, like, we are just basically creating an object, right, of the menu page class. And this object allows us to execute logic, similar to Java, like how you can import like jpanels and the likes. So we can also import page components and create instances of them. So this is essentially just shorthand, in the sense that we are creating this menu page, and then here we're creating this chatbot page, an instance of this chatbot page, you can see. And now we're also then creating an instance of this task assistant page, and then here we're creating an instance of the game page, and then that's essentially how we're essentially creating those respective pages, right? And then here, this is essentially just a function to save the messages after they've been typed, right? So if the database is ready, and then it awaits, it's always waiting, right? It's in a wait, so waiting for a message to be sent, and then after that it triggers a save, right? So it's executing that backend logic that we were demonstrating earlier on. And then here's another asynchronous task function where the shared message GTO is then called, right, as a parameter, and then now we then get the message as an async. And then we set the limit to 100. I don't think we're gonna get any more messages than 100. Yeah, and then we then return the databases. Yeah, then we then get the databases ready, and then we await shared repository, and then we get the recent messages, a limit of 100. This is mainly just for like the UI, right? It's just for the UI, so that the UI doesn't look ugly. I mean, for demonstration purposes, I mean, we can remove the limit. I don't think we even need the limit, to be honest. And then we can have yeah. So here we have the main memory GTO, and similarly we return database is ready, and then we await, make sure that we await, and then on this chat repository object, right, we then execute this function. So we get the menu memory summary from the database, right? And then here we then have our save reminder function, right? And then we have our instance of the reminder DTO, and then our instance of the reminder DTO, right, we then use the chat repository object, of course, then to access the method to save the remind async function and instantiate it on the reminder object. And then, yeah, similarly to this, so it's mainly, this is just mainly just the database saving, database saving. So we're just saving everything the database, and then it's just UI to say if it is ready, if it's connected, if it's initialized, it should toggle. So it should change the foreground, right? So that we can see if it is ready. So it lights green if it's ready, and if it's still pending, it's orange. So this is just UI design logic that is being showcased here. And yeah, so that's essentially it. And then when the session is ended, this is our logic where the session is ended for the specific username, right? And then if that username is saved, so that username is also saved in the database. And then that's essentially the main logic, right? Yeah. Let me see what else matters here. Okay, so within the games page. Okay, so let's go to the logic. So within the games page, right? These are our questions. So it's just a list of game questions, and then within that list, right, of game questions, so we have this object of this list, right? So we're gonna use this object, and then we have the host main window, and then we have the task voice. So the task voice, okay, so this is a nice way of just instantiating our objects. So our host is our person, and then our task voice is what we're gonna be. Yeah, so we're basically getting an instance of the task voice class. But let me just write this like this. Yeah, I don't know. Let me write it like this. I don't know. I like it like this. This is my preferred. I know people say it's verbose, but I prefer it like this. Okay. So yeah. So now here within this new object, right? Yeah. So private int current question index, then our score. So this score is when we get things right, when we get things wrong. It counts when things are correct. So it counts the truths, not the falses. So what we do is we initialize the component, the main window, right? Host. Right. And then after that, we go to the page load function, and then we show our questions. You just show our questions. It's a function, simple. And then we go after that to this click event, and then on the host, we then have the host object. Then we can navigate to the menu, which is the back button, and then the public async true button click, right? That's the true button. Like when you say true or false, this is the button, and then we await the answer, the question async, and if the answer is true, if it is true, the mapping is here. Right, the mapping is here of what is true and what is false. So if it is true, indeed, right, yeah, then it's awaiting for that, and then also it's also waiting if the answer is false, if it's supposed to be false. So now we have just programmed that logic. So now we need to have some sort of logic in the sense that we need to keep a record of what is happening. So that's why we have this iteration, this plus plus there, to basically have a count so that we can have to know where we are in the index of question number one, and then we're also keeping our score here. So here is basically just so here it will be counting. It will be counting all of the correct answers. Then if they're wrong, not quite. So if that's right, on the task voice object, that's when we then play our voice like good job. And then if it's wrong, then it gives us the negatives. And then if the current question index, the question count, the game complete, and the lights. So all of these are the various all the various logic that resides in the application. Then the menu page. And then the menu page. Similarly, we then have our function to show the banner. We have our welcome voice on the voice object, right? And then we have the welcome, and then we have the host. And then within the host that we have saved in the database, we're able to access the username field if it is there. And then we have the text that says loading memory. It loads the memory, right? Wait, after that it just loads memory. It's very cool. And then it gets the memory summary, right, on the host object, right? So the host object has their data, right? And then we basically build the memory text so that we can fetch that. And then we're just using FullCode fonts to create our ASCII banner. So this is the function for the ASCII, and then we build the memory. And then after that we have basically all of our operations. So on the host object we can navigate to the chatbot. On the host object again we can navigate to the task assistant. On the host object we can navigate to the game. So the host is able to navigate to all these various pages that they are ascribed to, or they want to go to. So that's essentially the entire code demonstration, right? And then there's a readme file on the setup on how everything is done. Okay, readme. I opened the wrong file. Okay. So this is the readme that shows how to essentially how to start the application and just .NET Restore, build, and then run. And then because there's a database backup, or even if there's no database backup, it's pre-configured to work with the database you set up, and then everything should be fine. All right, thank you so much.